Hi friends, you are welcome to your favorite learning channel, that is Royal Learning Channel. My name is Oluwatoyin. Today we are going to discuss about alkanal. Then alkanal is also known as aldehyde. That is another name for aldehyde. In today's topic, I'm going to explain physical properties of alkanal. Then I will explain method of preparation of alkanal. I will explain physical properties of alkanal and method of preparation of alkanal. Alkanals are carbonyl compound. They are carbonyl compound. Then what is the meaning of carbonyl? Carbonyl. What is the meaning of carbonyl? This is when carbon atom from the functional group of any organic compound is double bonded with an atom of oxygen. This is when carbon atom from the functional group of any organic compound is double bonded with an atom of oxygen. So the carbonyl, let's take for example of carbonyl compound is carboxylic acid. Carboxylic acid. Then carboxylic acid is also known as alkanoic. Then what is the general formula for carboxylic acid? That is RCOOH. RCOOH. Then the structural formula for this RCOOH will be RC double bond O, then OH. So we can see from this structure that the carbon atom from the functional group, the functional group is COOH. So the carbon atom from the functional group is double bonded with an atom of oxygen. So it shows that it is what? It is a carbonyl compound. So any organic compound in which the carbon atom from the functional group is double bonded with oxygen is what? Is a carbonyl compound. Then alkanal has a general formula of RCHO. Alkanal has a general formula of RCHO. Then the structural formula will now be RC double bond O and H. So we can see that the carbon atom from the functional group is double bonded with what? With an atom of oxygen. So that is why we say that alkanal is also what? Is a carbonyl compound. Then the general formula of alkanal can also be written as CnH2n plus 1, then CHO. CnH2n plus 1 CHO. Then don't forget that CnH2n plus 1 is what? Is the general formula for what? For an alkyl group. R is an alkyl group. So R is what? CnH2n plus 1. So you derive the molecular formula for members of alkanal from this general formula. So you use this general formula to derive the molecular formula for members of what? Members of alkanal. Now the first member is called methanal. Then don't forget that alkanal, I explained in my video under IUPAC nomenclature that alkanal is derived from what? A corresponding alkane, by substituting E at the end of alkane with what? With R. Alkane. They are derived from what? From alkanes. So by substituting the E with what? With R. So the first member now will be what? Methanal. The first member of alkanal is what? Is methanal. While the second member will be ethanal. The third member will be propanal. The fourth member will be butanal. The fifth member will be pentanal. The sixth member will be hexanal, followed by heptanal, then followed by octanal, then nonanal, and decanal. and decanal. So these are the first 10 members of what? The first 10 members of alkanal. The first 10 members of alkanal. Then the molecular formula for the first member will be, don't forget the number of mole. N means the whole number. N is whole number. So the whole number, that is the number of mole for the first member, is 0. Number of mole for the second member is 1. So for the third member is 2. The fourth member is 3. The fifth member will be 4, and so on. So if you want to get the molecular formula for the first member, substitute O into this what? General formula. Substitute 0 into this general formula. C times 0 will give me 0. So C gone. 2 times 0, 0 plus 1, that is 1. So we'll be left with 1 hydrogen then with your functional group. So this is the what? This is the molecular formula for methanol. HCHO. HCHO. Then the second member, N is 1. Substitute 1 into this formula. C times 1, that is C. That is C. 2 times 1 is 2 plus 1, that is 3. So CH3, then followed by your functional group. So CH3, CHO is the molecular formula for ethanol. So you can derive the molecular formula for other members from this general formula, Then it is possible to have a substituent. Then don't forget that from the structure under IUPAC nomenclature, your substituent can be an alkyl, it can be an atom, then it can be what? A group of atoms. So to learn more about that, check one of my video on IUPAC nomenclature of alkanal. So let's move to the physical properties of alkanal. What are the physical properties of alkanal? What are the physical properties of alkanal? The first member, which is methanol, is in gaseous form. Methanol is in gaseous form. Methanol is in gaseous form. So while other members can either be what? Liquid or solid. They can either be liquid or solid. So the first, number 2, from the first member to the fifth member are polar. They are polar. That is, they are soluble in what? In water. The first member to the fifth member are soluble in water. That is, they are polar. While other members are non-polar. So therefore, they are soluble in what? In organic solvents. They are soluble in organic solvents. That is number 2. Then number 3, 40% of methanol, 40% of aqueous solution of methanol will lead to the formation of formalin. Then what is the function of formalin? We use formalin in biology, in preservation of specimen in biology. We use formalin for preservation of what? Of biological specimen. We use formalin for preservation of biological specimen. So those are the physical properties of alkanal. The physical properties of alkanal. So let's talk about preparation of alkanal. Method of preparation of alkanal. What are the methods of preparation of alkanal? We have 2 methods of preparation of alkanal. I'm going to explain oxidation reaction. oxidation reaction. Then number 2 is addition of water to alkyne. Addition of water to alkyne. So let's first talk about oxidation reaction. Then oxidation of corresponding primary alkanol. Oxidation of, that is incomplete. Don't forget that the under oxidation of alkanol, we have primary alkanol, we have secondary alkanol, then we have tertiary alkanol. It is only primary alkanol that can oxidize to alkanal. It is only primary alkanol that can oxidize to alkanal. And under oxidation of primary alkanol, we have complete and incomplete oxidation. So that chemical reaction is of 2 stages. We have incomplete oxidation. Incomplete oxidation of alkanol will lead to what? Alkanal will lead to a corresponding alkanal. So under here, we are talking about incomplete oxidation of primary alkanol. Incomplete oxidation of primary alkanol will lead to what? A corresponding alkanal in the presence of acidified K2 K2Cl2O7 or KMnO4 as an oxidizing agent. So we use K2Cl2, acidified K2Cl2, O7 or KMnO4 as well as oxidizing agent. As oxidizing agent. Now, prepare the first member. Let's prepare the first member of alkanal, which is what? Methanal. So therefore, we use the first member of what? Of alkanal. We use the first member of a primary alkanal. So what is the first member of a primary alkanal? That is methanol. Methanol is the first member of a primary alkanal. Then the formula for methanol is CH3OH. CH3OH. Then I derive this formula from the general formula of alkanol, which is CnH2n plus 1OH. So this is the general formula for alkanol. This is the general formula for alkanol. Then now to derive the first member, you substitute 1 into this general formula. If I want to derive the first member of alkanol, which is methanol, I will substitute 1. Since methanol is the first member, I will substitute 1 into this general formula. So C times 1 will give me C. Then 2 times 1 is 2 plus 1, that's CH3, then plus your functional group OH. That is how I derive the general formula, the molecular formula for methanol. Then this reaction will take place in the presence of what? Of an oxidizing agent. That is acidified what? KMnO4. So you can use any of these words, oxidizing agents. Then what is oxidation? What is oxidation? Oxidation is the addition of oxygen. So this time around, we are going to add oxygen from our oxidizing agent. Addition of oxygen from your oxidizing agent, then we remove water molecule from the reaction. Now let me use chemical structure, that is the structural formula, to explain this chemical reaction. Then the first carbon atom with 3 hydrogen atoms. The carbon atom with 3 hydrogen atoms, then with your functional group. Then addition of what? Of oxygen. This oxygen is from what? From your oxidizing agent. So this oxygen is coming from your oxidizing agent. Why? Because oxidation is addition of oxygen. So you add your oxygen to the what? To the molecular formula of methanol from your oxidizing agent. That is why we are putting this oxygen inside but so because it is not an oxygen molecule, it is not an oxygen molecule, so it is coming from this oxidizing agent. So addition of oxygen, then you remove water. So let me first remove water molecule. So H and OH will give me H2O. That is addition of hydrogen to hydroxyion will give me H2O. So I've removed one what? One molecule of water from this structure. Then I will be left with what? C hydrogen, then another hydrogen atom, because I've removed this hydrogen and OH. Then oxygen coming in, then you add oxygen out, remove water and add oxygen, then add this oxygen from your oxidizing agent. Don't forget that oxygen will go with what? With double bond. So this is what? This is methanol. This is methanol. So we can convert this structural formula to what? Molecular formula now. So we add oxygen from our oxidizing agents. Then our product is now what? C. Our product is hydrogen, HCH. This hydrogen, then with carbon and hydrogen atom, then with what? With oxygen, HCHO. So this is the molecular formula for methanol. Methanol. So methanol. So our product is what? Is methanol. So that is how to prepare what? How to prepare members of alkanal by what? Oxidation reaction. So let's take one more example. Let's prepare the second member of alkanal. The second member of alkanal. The second member of alkanal is called ethanol. Ethanol. That is the second member of alkanal, ethanol. So we prepare ethanol from what? An alkane member. The second member of an alkane is what? Is ethane. Is ethane. So we prepare ethanol from what? From ethanol. From ethanol. Ethanol. That is C2H5OH. Don't forget that we are preparing alkanal from a corresponding alkanol. You prepare alkanal from a corresponding alkanol. So oxidation of, this is what? This is ethanol. This is ethanol. Then you add oxygen from your oxidizing agent. So our oxidizing agent is what? Acidified what? KMNO4. KMNO4. So addition of oxygen, then removal of water. Let's use structural formula to explain. Let me use structural formula to explain. So we have two carbon atoms. Then surrounded, each carbon atom must be surrounded with 4 chemical bonds. So 5 hydrogen atoms. 1, 2, 3, 4, 5. Then followed by your what? Your hydroxyion. Your hydroxyion. Don't forget that we are using what? We are using primary alkanol. You must use primary alkanol. Then how will you recognize a primary alkanol? When only one alkyl group is bonded to the carbon atom holding your functional group. When one alkyl group is bonded to the carbon atom holding my functional group. So CH3 is an alkyl group. C and 3 hydrogen atoms. That's CH3. So CH3 is an alkyl group bonded to the carbon atom holding this functional group. So therefore, ethanol is a primary. It is a primary alkanol. Then plus oxygen from our oxidizing agent. Plus oxygen. Don't forget that is removal of water, then addition of oxygen. So let's remove one water molecule. Let's remove water molecule. That is hydrogen and hydroxyion. That's water molecule. So minus H2O. So if I remove this water molecule, we'll be left with what? 2 carbon atoms and 4 hydrogen atoms. That's 1, 2. Then Here we have another H. Then addition of oxygen to this structure. Addition of oxygen to this structure. So if you want to add oxygen to this structure, don't forget that these two carbon atoms, they need what? One more chemical bond to balance. So we need one more chemical bond to balance this structure. But we are not going to balance with one more chemical bond, because oxygen is coming in with what? With its own double bond. So one of the hydrogen atom here will come here. One of the hydrogen atom will come here. Then this hydrogen comes up. Then oxygen will come in with what? With double bond. Oxygen will come in with double bond. So this is what? Ethanol. Ethanol. That is CH3CHO. This is ethanol, because an alkanal member with two carbon atoms is called what? Ethanol. So we have prepared the second member called what? Ethanol. Ethanol. So that is how to prepare what? Prepare members of alkanal by oxidation reaction of what? Of a primary alkanol. Oxidation of incomplete oxidation of what? Of a primary alkanol. Then let's move to the second method. The second method of preparation of alkanal. So we can prepare the second member of alkanal. We can prepare the second member of alkanal by addition of water to ethyne. So by the time you add water to ethyne, you prepare the second member of alkanal, which is ethanol, using dilute what? HSO4 and dilute what? H2SO4. So let's see the way we are going to prepare the second member of alkanal. Use what? Ethyne. So ethyne is C2H2. Then I'm going to use structural formula to explain. Ethyne with C2H2 plus what? Plus H2O. Since we said the reaction is what? Addition of water to ethyne will give us what? I'm going to use structural formula. This is the structural formula for ethyne. Then addition of water plus H2O. So the H2O will decompose to H and what? And OH. H and OH. So H and OH want to enter this place. Automatically, there will be what? There will be displacement of one double bond out of this triple bond. One of the triple bond will open. So when you open one of the triple bond, we'll be left with what? Double bond. Open one of the triple bond. Here we have hydrogen. Then there's another hydrogen here. We have hydrogen here. Then one hydrogen here. So we have removed one of the double bond. We have removed one of the double bonds. Automatically, it will attach to the two carbon atoms. So therefore, hydrogen will enter here. Then hydroxy ion will enter here. So the rearrangement of this structure rearrangement of the structure. Then the rearrangement of this structure will give us the second member of alkanal. So the hydrogen will come here for this double bond to open. So we have to open one of this double bond. When you open one of the double bond, I've opened one of this double bond, then hydrogen, then you open this double bond. You need one more bond there. Since you have opened one of these double bond, so the bond we attach to this carbon atom, we have OH here before, then we have hydrogen atom here before. So the double bond that open will attach to this place. So therefore, hydrogen what? Hydrogen atom will come here. Then the hydroxy group will now split to hydrogen and what? And oxygen atom. So the oxygen atom will go with what? Double bond. Then the hydrogen from the hydroxy group will go with what? A single bond. So this hydrogen, this structure will now be what? CH3CHO. So our product now is what? CH3, then CHO, which is what? Which is the second member of alkanal called hexane. We have come to the end of today's class. Remember to subscribe to Royal Learning Channel. Share this video with your friend and comment. See you in my next video. Bye.